Welcome to Two Projects. In this video, we are going to explain the project Indian Stock Market Price Prediction using machine learning and deep learning. So, before diving into the execution, let me give you an overview of the project. The project aims to predict future prices or trends of stocks listed on the Indian stock exchanges. Accurate predictions are crucial for investors, traders, and financial analysts to make informed decisions regarding buying, selling, or holding stocks. Predictions help traders manage risks associated with their investment portfolios, aid financial analysts in analyzing market trends and identifying investment opportunities, and maximize profits by timing trades effectively. So, machine learning and deep learning techniques play a vital role in stock price prediction due to their ability to analyze large volumes of historical market data and identify complex patterns and trends. Machine learning models can learn from past market behavior to make predictions about future price movements, while deep learning models capture temporal dependencies and non-linear relationships in the data. So, the dataset used contains financial data related to the Nifty 50 index, including date, opening price, closing price, trading volume, and other relevant financial metrics, providing valuable insights into the performance and trends of the Indian stock market over the past 3 years. And exploratory data analysis is used to check for null values, duplicates, and visualize the data to gain insights into its distribution and trends. Data pre-processing involves techniques like min-max scaler to scale features and ensure data is suitable for model training. So, various machine learning models such as support vector regression, k nearest neighbors, decision tree, random forest, etc., ensemble techniques like voting classifier and stacking classifier, deep learning models including RNN, LSTM, GRU, etc., are utilized. So, the primary objective of the project is to provide stakeholders with valuable insights into market trends and empower them to make informed investment decisions in the dynamic Indian stock market landscape. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3, and front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll understand about the algorithms used in brief. So the first algorithm built is support vector regression, that is SVR. SVR is a machine learning algorithm used for stock price prediction, focusing on minimizing the error between predicted and actual values within a specified margin. It effectively handles nonlinear relationships, outliers, and high dimensional data, making it a valuable tool for accurate stock price forecasting in the Indian stock market. The next algorithm built is k nearest neighbors, that is KNN. So KNN predicts a data point based on the majority class or average of k nearest data points. It captures local patterns in data and does not make strong assumptions about the underlying distribution, making it useful for stock price prediction tasks. The next one is decision tree. Decision tree splits dataset into subsets based on significant features. It can handle categorical and numerical data, capture complex interactions, and provide interpretable results, making it suitable for stock market analysis. The next algorithm built is random forest. Random forest uses decision trees to construct multiple trees independently and combine for predictions. It is suitable for high dimensional data, capturing complex relationships between features and target variables, and providing robust predictions, making it effective for stock price prediction tasks. The next one is extreme gradient boosting, that is XGBoost. XGBoost trains weak learners to correct errors, combining their predictions to create a strong predictive model. It is suitable for large data sets and complex financial market data, making it a powerful tool for accurate stock price prediction. The next one is AdaBoost. AdaBoost combines weak learners into a strong classifier, focusing on difficult to classify examples. It is used in this project to improve prediction accuracy in stock market data. The next algorithm built is NIBASE. NIBASE is a probabilistic classification algorithm based on Bayes' theorem, assuming feature independence. It performs well with categorical data and is suitable for predicting Indian stock market prices due to its efficient handling of multidimensional financial data. The next algorithm built is linear regression. Linear regression is used to model the relationship between a dependent variable and independent variables. It is useful in predicting Indian stock market prices by establishing a baseline model, understanding the direction and magnitude of features influence on stock prices. The next one is ANN, that is artificial neural networks. So ANNs are machine learning models that can learn complex patterns in stock market data, making them ideal for time series prediction tasks like forecasting Indian stock market prices inspired by biological neural networks. The next one is stacking classifier. So, the stacking regressor is an ensemble learning technique that improves stock price predictions by combining multiple Bayes regressors. In this case, random forest regressor, gradient boosting regressor, and linear regression. And a meta regressor, which is also a linear regression in this instance. It effectively handles complex relationships and non-linear interactions in financial datasets like the Indian stock market. The next one is voting regressor. So, the voting regressor is an ensemble learning technique that uses multiple regressors to predict Indian stock market prices. It uses random forest regressor, gradient boosting regressor, and linear regression as base regressors, enhancing prediction accuracy and robustness. This approach captures market dynamics and combines different regression algorithms for reliable predictions. The next algorithm built is recurrent neural networks, that is RNN. So, RNNs are deep learning models that handle sequential data by updating hidden states iteratively. They capture temporal dependencies and patterns in data, making them ideal for time series forecasting tasks like stock price prediction in Indian stock markets. The next one is LSTM. So, LSTM, that is long short term memory, is a recurrent neural network architecture that captures long term dependencies in sequential data, making it ideal for time series prediction tasks like stock price forecasting, where understanding past patterns is crucial. The next one is GRU. So, GRU is a recurrent neural network ideal for sequence modeling tasks like stock market price forecasting. It uses gating mechanisms to capture long range dependencies and temporal patterns, enhancing prediction accuracy in complex relationships and patterns. The next algorithm used is BiLSTM, that is bidirectional long short term memory. So, BiLSTM is a neural network architecture that captures long range dependencies and temporal patterns in sequential data. It consists of two LSTM layers processing input in forward and backward directions, enhancing understanding of stock market dynamics. The last algorithm built is CNN plus LSTM. So, the combination of CNN and LSTM model combining CNNs and LSTMs effectively predicts stock prices by extracting spatial and temporal patterns from stock market data. This model is suitable for capturing complex trends and long term dependencies in Indian stock markets. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So, this is the static folder in which I have files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is dataset file in which I have data related to the Nifty 50 index spanning 3 years. It provides a comprehensive financial data for the Indian stock market, including key metrics like date, opening price, highest price, lowest price, closing price, adjacent closing price, and trading volume. So, this data is crucial for analyzing trends, volatility, and performance in the market. So, on this data, we will train the machine learning and deep learning models. This is app.py file. This .py file contains the information related to front-end logic. It includes code data in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is Notebook Jupyter source file, which contains a combination of code, graphs, and outputs all in one place. So Jupyter source file allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Now use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see sign in and sign up links. Click on sign up link. So if we are new users, we have to register ourselves first, fill in all these details and click on sign up button to register. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on the sign in link. Here we have to give our credentials, username and password and click on sign in button. So it has redirected us to the predictions page. So here we can see a place where we have to enter the company ticker symbol. So company ticker symbols are abbreviated codes used to identify publicly traded companies on stock exchanges. They consist of letters or numbers and are used in financial markets for trading purposes. For example, Apple's ticker symbol is AAPL and Microsoft's ticker symbol is MSFT. So here we have to provide ticker symbol as input. This is the ticker symbol of Nifty 50. Now click on Go button. It will take some time to load. So here we can see today's Nifty 50 stock data. This is the opening price. This is highest price. This is lowest price. This is today's closing price. And these are other data relevant to Nifty 50. And if we scroll down here, we can see a line graph which depicts the fluctuations in stock prices over a span of 3 years from 2021 to 2023. Scroll down and here we can see the graph which shows how well the linear regression model predicts values. So the red line is what actually happened and the blue line is what the model predicted. So the two lines are very close, which means the model did a good job predicting. Similarly, These are the accuracy graphs of other models built. This is the RNN models accuracy graph. This is LSTM models accuracy graph. This is GRU models accuracy graph, and this is BioLSTM models accuracy graph. We can see there is a huge difference between actual and predicted prices, which means these models are not performing well. Scroll down. Here we can see tomorrow's Nifty 50's closing price predictions. So this is the tomorrow's closing price of Nifty 50 predicted by linear regression model. This is the tomorrow's closing price of Nifty 50 predicted by RNN model. Similarly, these are the tomorrow's closing prices of Nifty 50 predicted by these models LSTM, GRU and BioLSTM. So here green color represents the models are doing well. Yellow color represents the model is performing neutrally, and the red color represents the models are not performing well. And scroll down. Here we can see the RMSE scores of the built models. The model with the least RMSE score is the best performing model. And we can see linear regression has secured the least RMSE score among all other models. So we will take the predictions of linear regression into consideration. So tomorrow's closing price is 21980.03. So we can try the same with other ticker symbols also. Click on back. So we'll try giving another company's ticker symbol. So we'll give the ticker symbol of Wipro. Now click on go. It will take some time to load. So here we can see today's Wipro's stock data. This is the opening price, highest price, lowest price, today's closing price. And these are other relevant data. And we can see the same in official Wipro's website also. So if we type wipro.ns here, so this is the closing price they are displaying. So we can see we have the same here. And if we scroll down, here we can see the line which depicts the fluctuations in stock prices over a span of 3 years, 2021 to 2023. And this is the accuracy graph of linear regression. So as I mentioned, the blue color line is what the model predicted and the red color line is what actually happened. So we can see there is no much difference, which means the model is doing well. And these are the accuracy graphs of other models, and we can see there is difference seen. And here we can see the closing prices of tomorrow of Wipro company predicted by these models. And here we can see the RMSE scores of different models. The model with least RMSE score is the best performing model, and we will take the predictions of that model into consideration. And we can see the linear regression's RMSE score is the least, and we will take the prediction of linear regression into consideration. So tomorrow's closing price of Wipro is 479.58. So similarly, we can try giving different ticker symbols of different companies and can get the tomorrow's closing price predictions. Click on back, enter the ticker symbol here. I'm giving it as SBI.NS. Click on go. So it is a wrong ticker symbol. We'll try again. Click on go. We have to enter the correct ticker symbol. Let me try with SBIN.NS. Click on go. It will take some time to load. So here we can see today's SBI's stock data, opening price, highest price, lowest price, today's closing price, and other data. This is the line graph showing us the fluctuations in stock prices over a span of 3 years, 2021 to 2023. This is the accuracy graph of linear regression model. This is the RNN's accuracy graph. Similarly, these are the accuracy graphs of other models. And here we can see the predictions of closing prices predicted by these algorithms. And these are the RMSE scores of the algorithms built. The algorithm with the least RMSE score will be considered. And we can see linear regression has secured the least RMSE score of 8.81 among all. So we will take the predictions of linear regression into consideration. So tomorrow's closing price of SBI would be 739.98. Now click on logout. So the conclusion here is linear regression has demonstrated superior performance among various models in predicting Indian stock market prices in this project. Through seamless integration with Flask, we have developed a user-friendly web interface for accessing real-time stock data and predictions. This project holds significance in providing valuable insights into market trends, benefiting investors, traders, and financial analysts in making informed decisions. By allowing users to input company ticker symbols, Flask enables retrieval of today's stock prices and visualization of predictions generated by diverse algorithms. And the incorporation of real time data and multiple prediction models equips users with a comprehensive tool set for navigating the dynamic Indian stock market landscape.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.